Next important concept is half-range Fourier series. Till now, we discussed Fourier series expansions in the intervals 0, 2 pi and minus pi, plus pi. Now, we are going to discuss the half-range Fourier series in the sense 0, pi. Pictorially, 0, this is pi and this is 2 pi. Suppose this is your graph, suppose this is the graph of your function. Till now, we discussed on these graphs. Suppose this is your function. Okay, if we calculate the Fourier series expansions in the interval 0, 2 pi and minus pi, plus pi for the functions f of x. Now, we are going to discuss the half-range Fourier series, nothing but from 0 to pi. From 0 to pi, isn't it? In this, we have only two formulas, only two important formulas, that is half-range cosine series and half-range sine series. Okay, how we write it? Suppose this is a graph of your function f of x. Since it is periodic function, we will write like this. If you want to extend your function f of x as even, that is even periodic extension. If you write an even periodic extension, you got this function as even function. Then we get only half-range cosine series. Then we get half-range cosine series. Suppose if you extend your function as an odd periodic extension, then your function will become an odd function. Then you got an odd function and hence we can frame a half-range sine series. Half-range sine series. Simply in one word, you can frame out a function f1 of x which is identical to f of x in the interval 0, pi as an even function. If it is an even function, then it will become an half-range cosine series in the limit minus pi, in the limit minus pi, plus pi. So, then we write only half-range cosine series formula. If you take an odd function in the limit minus pi, plus pi, that is, if you write a function f2 of x which is identical to your function f of x, and if it is an odd function, then we can write a half-range sine series. That formula is, for sine series, half-range sine series, your formula is f of x equal to sigma n equals to 1 to infinity bn sin nx, where this bn equal to 2 by pi integral 0 to pi f of x sin nx dx. And similarly, for the second formula, half-range cosine series. Here you have only cosine terms. So, the formula is f of x equal to a naught by 2 plus sigma n equals to 1 to infinity a n cos nx, where a naught equals to 2 by pi integral 0 to pi f of x dx and a n equal to 2 by pi integral 0 to pi f of x cos nx dx. Okay? Yes. Please, you just follow these two formulas on solving the problems. Okay? In this concept also, we will discuss Fourier series expansion for continuous function and for discontinuous function. Okay? Now, let us see the first problem. Half-range cosine series for the function e power x. You know that this is clearly a continuous function. So, we are going to calculate the half-range sine series for continuous function. Half range in the sense, clearly your interval is 0, pi here. So, first write down your function. What is your function? F of x equal to e power x. And your interval is 0, pi. They ask you to calculate the half range sine series. So, which formula you have to select? First formula or the second formula? Yes. Second formula. You have to select the second formula. Take down this second formula and apply to the function f of x. Then the half range sine series expansion of the function f of x equal to e power x in the interval 0, pi is given by e power x equal to sigma n equals to 1 to infinity bn sine nx. Okay. Now calculate bn. What is the formula for bn? Bn equal to 2 by pi integral 0 to pi f of x sine nx dx. Now write the value of f of x. What is your function? E power x. Substitute e power x in place of f of x. Then you got 2 by pi integral 0 to pi e power x sine nx dx. Now here, in order to integrate this value, you have to use this formula. That is integral e power ax sine bx dx equals to e power ax by a square plus b square into a sine bx minus b cos bx. Now what is your a value here? Your a value is 1. And what is your b value? B value is n. Now substitute these two values in this formula. You get this value 2 by pi e power x by 1 square, nothing but 1. 1 plus n square, brackets begin, 1 into sine nx minus n cos nx, substituting the limits, applying the limits 0 to pi. Now substitute the limits. First apply the upper limit, you got this value, and then apply the lower limit, you got this value. Now use the formulas sin n pi equal to 0, cos n pi equal to minus 1 power minus n, minus 1 power n, sin 0 equals to 0 and cos 0 equals to 1 here. Finally, you got the value of Bn is this one, that is 2n by pi into 1 plus n square into minus 1 power n plus 1 e power pi plus 1. Just substitute the value of Bn in equation 1. Okay, now substituting and expanding the summation, you get your required Fourier series expansion. Expansion in the sense, put n equals to 1 first and then n equals to 2, add it up. Then we get 2 by pi, brackets we can take common 2 by pi overall, then 2 by pi 1 plus e power pi by 1 square plus 1 sin x plus 2 into 1 minus e power pi by 2 square plus 1 into sin 2x and so on. Is it clear? Just identify the formula. First, what type of function is it? And what they asked, half range sine series or half range cosine series? If it is half range sine, then take the corresponding formula, calculate the value of Bn, substitute it. You get the result. Now, move to the second problem. What is your second problem? Read out first. Express f of x equals to sin x as a Fourier cosine series in 0, pi and show that this result. They gave you one direction. We have to show one direction. Now, they gave you a function f of x equals to sin x. Clearly, this is a continuous function. They asked you to express the given function as Fourier cosine series. The alternate name of cosine series is half range cosine series is Fourier cosine series. If they ask you to calculate Fourier cosine series, you have to take the formula of half-range cosine. Similarly, if they ask you to find out Fourier sine series, you have to take down the formula for half-range sine series. Now, which formula you have to select? Half-range cosine series, the first formula. By using this formula, to the function f of x equal to sin x, write down the half-range cosine series or Fourier cosine series for f of x equal to sin x as sin x equal to the formula, substituting in your formula, sin x equal to a naught by 2 plus sigma n equals to 1 to infinity a n cos n x. Let it will be equation 1. Next, what we have to do? It remains to calculate only a naught value and a n value. So, write down the formula for a naught. What is the formula for a naught? The formula for a naught is, see here, a naught is equal to 2 by pi integral 0 to pi f of x dx. Okay. Now, substitute the value of f of x in your formula. Then, we get a naught equal to 2 by pi integral 0 to pi. In place of f of x, you have to write sin x. So, sin x dx. Now, calculate the integration and apply the upper limit and lower limit. You get 4 by pi. So, what you got? We got the a naught value as 4 by pi. Keep it aside. Next, calculate a n value. Take down the formula for a n. What is the formula for a n? 2 by pi integral 0 to pi f of x cos nx dx. Okay, here also you have to substitute the value of f of x as sin x. Okay, now observe this one. Here you have 2 sin x cos nx dx. You have 2 sin x cos nx dx. This is of the form 2 sin a cos b. This is of the form 2 sin a cos b. Now apply these formulas. You get 1 by pi integral 0 to pi sin a plus b. Here a is 1 and b is n. A is 1 and b is n. So, a is 1 and b is n. So, sine of 1 plus n into x plus sine of 1 minus n into x dx. Okay, now on integration, while integrating this one, this sine 1 plus nx, 1 plus n into x is nothing but minus cos 1 plus n into x by 1 plus n, and similarly here we got minus cos 1 minus n into x by 1 minus n. Now apply the upper limit and lower limit. If you substitute the upper limit, you got, take down minus 1 as common. So, minus 1 by pi cos 1 plus n into pi by 1 plus n plus cos 1 minus n into pi by 1 minus n. So, you substitute the upper limit. Now, it's the time to substitute lower limit. What is your lower limit? 0. So, cos of 1 plus n into 0, nothing but cos 0. Cos 0 by 1 plus n plus cos 0 by 1 minus n. Here you have to use the formulas cos a plus b. I wrote it here. See this? Cos a plus b and cos a minus b. Okay. Now, I already calculated here. Cos, it is 1 plus n into pi, nothing but cos pi plus n pi, isn't it? So, write down here cos pi plus n pi, applying the second formula, that is cos pi cos n pi minus sin pi sin n pi. You are all familiar with cos n pi. What is cos n pi? Minus 1 power n. So, cos pi will be minus 1. What is sin n pi? Nothing but 0. What about sin 0? 0. And what about sin pi? It's also 0. So, this value will be equals to minus 1 power n plus 1. And also similarly calculate cos of pi minus n pi. We got this value. Now substituting those two values, you can get this value as minus 1 by pi of this one. Now after simplification, finally you got an equal to 2 into 1 plus minus 1 power n by pi into 1 minus n square. Clearly n not equals to 1. Here 1 minus n square, clearly n not equals to 1. So for n equal to 1, what happened? So you need to calculate for n equal to 1. Okay, so for n equal to 1 means in place of an you have to calculate a1. So write down the formula for an first and substitute n equals to 1. You get the formula for a1. So what is your an? Your an is, see this formula, 2 by pi integral 0 to pi f of x cos nx dx. Then what happened if n equals to 1? a1 equals to 2 by pi integral 0 to pi f of x cos n means 1 cos x dx. I just wrote it here. Now substitute the function f of x equal to sin x, and here it is cos x. What is the formula for 2 sin x cos x? Nothing but sin 2x using this formula. So applying this formula and integrating and substituting the upper and lower limits, finally you got a1 equals to 0. So till now you calculate the values of a0, a1 and an. Substitute these three values in equation 1. Okay, what is your equation 1? Your equation 1 is sin x equals to a0 by 2 plus sigma n equals to 1 means here a1 cos x. Okay, plus sigma n equals to 2 to infinity an cos nx. Now, substituting a0, a1, an in equation 1, we get sin x equal to 4 by pi by 2 plus 0 cos x plus sigma n equals to, you already substituted n value, n equals to 1 here. So here n runs from 2 to infinity, the an value, that is 2e by pi 1 plus minus 1 power n by 1 minus n square cos nx. This is your required Fourier series expansion. Now this can be expanded. After expansion, you got sin x equal to 2 by pi plus 4 by pi sigma n equals to 2, 4, 6 up to infinity cos nx by 1 minus n square. Because if you observe, the first and third and remaining terms or terms will get 0. So I can write the summation in this format. Okay, now this will be equal to sin x equals to 2 by pi minus 4 by pi sigma n equals to 1 to infinity. I can write this one as cos 2nx by 4n square minus 1. Here all n's are even. Okay, I can write this one as n equals to 1 to infinity cos 2nx by 4n square minus 1. Just replacing n with 2n, so that your value will become n even 1. So 2, 4, 6, that is cos 2nx by 4n square minus 1. Now this will be a required half range Fourier cosine series. Okay, now we have to deduce the relation. Which term, what is the value of x, suitable value of x to get the summation sigma n equals to 1 to infinity 1 by 4n square minus 1. See your summation. For what value of x this term will become 1? What it will be? Automatically at x equal to 0, you will get the cos 2nx will be equal to 1. So put x equal to 0 in equation 2. Let it will be equation 2. So put x equal to 0 in equation 2. We get sin 0 equal to 2 by pi minus 4 by pi sigma n equal to 1 to infinity cos 0 by 4n square minus 1. Okay, here it is. Cos 0 is nothing but 1. 1 by 4n square minus 1. Sine 0 equals to 0. So after simplification, you got sigma n equals to 1 to infinity 1 by 4n square minus 1 equals to 1 by 2. Okay, which is our required result. Is it clear? Next, move to the next problem. Problem 3. See your function. Observe your function. What is your interval? What they asked. Here your function, clearly it is a discontinuous function. Your interval is 0, pi. Your interval is 0, pi. But what is the point of discontinuity here? Pi by 2. Pi by 2. That means from 0 to pi by 2, your function value is f of x equal to x. And from pi by 2 to pi, your f of x is pi minus x. They asked you to calculate half-range sine series and also half-range cosine series for this discontinuous function. And this problem can also be asked like this. Show that f of x equals to 4 by pi into sin x minus 1 by 3 square sin 3x plus so on, and show that f of x equal to pi by 4 minus 2 by pi into 1 by 1 square cos 2x plus so on. If you observe, this is the indirect manner to ask the above problem. Okay, now see this one. They gave you a function, a discontinuous function. First, write down your function. Observe the interval. Your interval is 0, pi. They asked you to calculate half-range sine series. So, take the second formula. Take the formula for half-range sine series. That is f of x equal to sigma n equals to 1 to infinity bn sin nx. Let it will be equation 1. Now to find out bn, write down the formula for bn. What is the formula for bn? 2 by pi integral 0 to pi f of x sin nx dx. Okay, now since it is a discontinuous function, your integral value 0 to pi can be divided into, can be split into 0 to pi by 2 and pi by 2 to pi. Write down 2 by pi integral 0 to pi by 2 f of x sin nx dx plus integral pi by 2 to pi f of x sin nx dx. Now write down the function value of f of x in the interval 0 to pi by 2. What is the value of your f of x in the interval 0 to pi by 2? In the interval 0 to pi by 2, my function f of x equals to x. Just substituting that f of x value here. Now, similarly, your f of x value in the interval pi by 2 to pi is pi minus x. Integrating and evaluating the values, finally you got bn equal to 4 by pi n square sin n pi by 2. Clearly, n not equal to 0. Now, substituting this bn value in equation 1, you got f of x equals to sigma n equals to 1 to infinity 4 by pi n square sin n pi by 2 into sin nx. Now, expanding the summation, you got sin pi by 2 by 1 square into sin x plus put n equals to 2. 4 by pi, already taken out. So, sin 2 pi by 2 square sin 2x plus so on.